right, here we are.
Hello.
Finally back. Today is going to be really interesting because we're going to do something we don't often do. In fact, I would even go as far as to say sometimes we avoid doing what we're going to do today. We are going to talk about both ECS and EKS in the same show. So, yeah, I mean, this is, get ready, folks. We're going to probably have phone calls from all kinds of people after this. So what we're going to do, though, is we're going to do it in context of talking about how to run stateful workloads with your favorite container orchestrator. And of course, that means we're going to talk about ECS and we're going to talk about EKS. So stateful workloads. For the longest time, my recommendation, in fact, if you've ever met me in person at a conference and walked up to me at the booth and you said, Brent, how can I run stateful workloads? Or, but what about stateful workloads? What should I do there? If you've ever said that to me, my answer has always been, just don't. Just stop. Just like keep it stateless. That's easy. That's the low-hanging fruit. I think today, though, we can pretty easily say we might be past that. The low-hanging fruit has been addressed, and now we're on to the next level of stuff that we can tackle. And frankly, stateful workloads that's in there. So what are the gotchas? What do we need to be on the lookout for, and how can we best tackle stateful workloads? So we have always get it wrong. We have Will joining us today, and he's going to talk to us. Will, in fact, Will, why don't you introduce yourself?
Sure. Hey, guys, thanks for having me on today. I'm Willow Chandarina. I am a product manager with the Amazon EFS team.
Awesome. So we're going to talk EFS today. And I've gotten to where, over time, as I've been, adopting and using stateful workloads, I find EFS to be the easiest way to manage this stuff. So there are some advantages of EFS over EBS that you could think about. Do y'all have any thoughts on that, just real quick before we get into the nitty-gritty? Why EFS instead of EBS?
Will, do you want to take that?
Happy to. Yeah. So we have lots of storage options in the portfolio. They all have great use cases for them. In the context of containers, I think there's two main things about EFS that make them attractive and make them, like you say, easy. One is let's say what EFS is, Elastic File System. As the first word in that name suggests, it's an elastic file system. And the easy part about that means that you don't have to know ahead of time how much data that you're going to store, and you never have to worry about filling it up. So the act of just creating a file system and then being able to attach that to any app without really thinking about much else makes it really easy. That's the first thing. The second thing, and it's not in the name, is that it's shared, which means you don't have to worry about just attaching it to one thing, even though that might be what you want to do. So you can attach a file system to one task, two tasks, three tasks, 25,000 tasks.
Nice.
In the cases that make sense. And like I said, you might just want to attach it to one, but where the sharing aspect comes in handy is when you start thinking about things like failover. So let's say you first have your tasks spin up in one availability zone, and then you want to make sure that if anything happens to that task and it gets rescheduled in another availability zone, that it can connect. The fact that anyone can just up and connect to the file system makes that handy. And I guess this is technically a third thing, the fact that your file system is regional, so it actually is already in all of these availability zones, makes that really easy. Adam, is there anything you wanted to add?
Yeah, no, that was well said. Brent, go ahead. You were going to say something.
Yeah, I was just going to reiterate, because those are the precise reasons that my starting point is EFS. And, we like to talk about blast radius and We also and stuff like that. But we also then like to talk about serverless principles and pay for only what you use. And if you think about it, EFS is both of those things, because I can come up in one availability zone and my container can exist there. But if that availability zone starts to have problems, then my container is going to potentially have problems. If I'm tying it to an EBS volume, then of course that EBS volume is potentially also going to have problems. And those two things together can cause each other problems. Whereas if I'm on EFS, then that's regional. And my container that's having a problem in one AZ, can get killed off for a, I don't know, failed health check or a deployment or any number of reasons, and it can pop back up in a new availability zone and still have access to all the same data. And you can't do that today with EFS. So there are good reasons to use EFS too, but just like we're going to be talking about, I'm sorry, yes, there are good reasons to talk about EBS also. But just like we are, making choices, it's good to have choices, right? And so we're making choices about our orchestrator. We're making choices about our base image, that goes in our Docker container. Well, we can make choices about where we put our files. And those choices can have pros and cons. We can weigh them, and then we can make a decision. So that's kind of how I look at it. So we should dive in, and we should, because we have a lot to demo today. So who wants to start first?
I would say let's start with Will's demo, and then at the end, I'll do a nice little Copilot demo.
Oh, sweet. Okay,
put a little bow on top.
All right, so let's cut over to screen share.
Okay. So the thing that I wanted to demo today is, so it's an ECS and EKS show, and my demo is actually going to do both. The main focus of it is going to be highlighting the newest thing that we launched on the EKS side, which is EFS dynamic provisioning within the CSI driver. So but the way I'm going to demo it is actually by first connecting to my file system from an ECS container, and then hopping over to my terminal to do some EKS provisioning, and then show you guys what's happening behind the scenes as I do this, so that you can understand, A, that it works, and B, how it works.
Sweet.
Fantastic.
Now, to do that, so let's start off with just the EFS side. So here, just in the EFS console, I already created my file system. You didn't miss much there. I just clicked new file system and then OK. So it's got some stuff, but the thing that I want to show you, so there's two main things that your file system has. Access points, if you're doing containers and serverless and stuff, and mount targets. So mount targets, I'll just say really quickly, these are like the windows to your file system from each availability zone. So if you're going to have two applications in two different availability zones talking to the same file system, each is going to connect through its local mount target so that it has something local to connect to, and it's not making like cross AZ calls or anything like that. But access points are the thing that I do want to talk about, because these are really handy in the container world for two reasons. One is whenever you're connecting a container into your file system, one of the things that traditionally has been kind of hard to think about is the identity of the application and how that's going to manifest on the file system. So with a shared file system, all of your files and directories are owned by POSIX users. So if I'm like, take your traditional EC2 machine, you log in there and you are EC2 user, which is UID 1000. So if I were to connect to a file system and start doing stuff, it would start doing things as UID 1000, which may or may not be what I want. Now, the container equivalent is I can do a deploy of whatever container off of a public registry, and that container might be built to run as EC2 user, or it might be built to run as root or something like that. And if that's not the permission of the stuff on my file system, I'm either going to have way more access than I want or way less access than I want. And what you want is the right access. And that's why we build access points. So here, for just illustrative purposes, what I've done is I've created an access point named root AP. And the reason I called it root AP is it is a root access point, meaning it ties anyone that connects through it to the root path of my file system. And it ties all operations that come through that access point to the root user, which is UID and GID 0. So what this means is even if my container is built as EC2 user, but my files are owned by someone else, EFS, when we get those connections coming in, we will rewrite everything to user ID 0 so that now that container can access everything, which usually isn't a great idea, but for this demo, it works out really well because it means that now I can have an ECS container come in and be all-knowing, all-seeing.
And
go ahead, Adam.
I just wanted to add, and you're probably going to get here, but you can also control access to these access points through IAM, right?
Yeah.
So that's another great way that, you know, you're using IAM, you're using the AWS native, you know, identity service to control access to you don't have to control access through another layer, some other mechanism. It's the same one you use to control access to other AWS resources.
Yeah, great point. And I was going to forget to go there. So thanks for bringing it up. One way I think of this is it's kind of a bridge between cloud native authorization and traditional file authorization by combining these two things. So you create an access point and then you tie that to an IAM role. And now you've tied an IAM role to a NFS identity in essence. And you would just do that here with your file system policy, which if there's time, maybe we can come back to that. Sweet. So I've got my access point now. Let's pop over to ECS. So I've got a task called File Browser. I've iterated on it a few times. So I've got File Browser 6 now. And I'll just show you a little bit of the container definition. So we see where we've defined it in here. So there's EFS volume configuration. I put in the file system ID. I specified the access point ID, the one that we were just looking at, and said that I want to be in the root directory of that access point. And we'll talk about kind of like how that works.
So
go ahead.
The tech guy, I think you kind of have alluded to this, but let's just be explicit about it. He says, I'm guessing the user statement in Dockerfile is connected to this somehow. Actually, yes and no, in a manner of speaking, because the cool thing about the access point is you can map all user and identity to a specific user and identity for EFS. And so really it doesn't matter what the user statement is or if there is one or not. You know, if there's not a user statement, then the container is going to be running as root. However, all of those calls into the file system are going to be mapped to whatever the file system says they should be. In this case, it happens to be root. So did I get that right, Will?
Yeah, exactly. It's what I end up talking to a lot of people about is build time versus runtime kind of thing. So the user is, in most cases, a build time thing about the container. So every once in a while, people will turn that build time thing into a runtime thing by exposing I can pass an environmental variable into my container, and then it's going to run my app as whatever I set that variable to, which is nice if you want to do that, but it's never guaranteed that that's the way it's going to work. So oftentimes people just pull containers from public registries, run them, and have no idea what user it's running as. And until they connect to something like EFS, they wouldn't. And they wouldn't have to care either. But now it makes sense because if you have two containers connected to the same file system, you actually kind of care which privileges one has versus another, because you may want this app to be read-only and this one to be able to read-write, things like that. So this is my volume configuration. Really, as you can see, there's not much there. You just give it the file system ID and the access point ID. And then up in my container definition here we go. I just reference my source volume, say that I want to mount it into /data, and that's it. Now, I've already launched this container. It's running in Fargate, and the app that I'm running, probably log in here. It tends to log me out. Nope. Okay. So my file system is empty now. So I've got this. My app's a file browser because file systems are easy to see when your app is a file browser. So that's what we have there. So really, that's so far just the basic how to use EFS from ECS demo. Now, what I'm going to layer in here is some Kubernetes stuff now. So for that, so I've got a Kubernetes cluster already set up. It's not running anything yet. Sorry. Yep, I don't have any volumes yet. I don't have any pods yet. So we're kind of starting from scratch here. So what I have set up is, oh, here we go. So here is my definition for my pod and my persistent volume. So the big thing that dynamic provisioning does is it takes one of the deployment steps out of every time that you deploy an app. So before dynamic provisioning, what the developer or the admin, or maybe both sometimes, would have to do is first create a persistent volume, where a persistent volume was a pointer to a specific piece of AWS EFS infrastructure, which is a file system or an access point or both. With dynamic provisioning, what I've done is I've already configured some stuff in the background which told Kubernetes about my file system, but said whenever a user comes along and wants some storage, just provision an access point on the back end that will back that storage and then give it to the app, and then the app thinks it has its own file system, its own volume in essence. So what the user does in here is just twofold. One is it takes out a persistent volume claim against a EFS storage class, and I'll actually show you the config there. So all I had to do to configure this was named my storage class, and then I pointed it at a file system, and there's some other, I left everything else default pretty much. So now I point at that storage class. So when this persistent volume claim hits this storage class, it knows to send some commands to EFS to provision an access point and create some storage. And then it mounts that into my container under /data, just like my ECS container did. So let's run it now. So I'm going to do a there we go. So it created my claim, created my pod. Let's see. It created a PV and a PVC. Looking good. My pod is running, which means everything worked under the hood. So it wouldn't be running unless the storage actually came up and was connected to under the hood. Sometimes if you don't have security groups or something set up right, you get the dreaded container creating here. So now let's see what actually happened on the back end. So first, let's go to EFS. I'm going to click refresh. Now I have a new access point here. So this access point, I can see in my path here that it's deployed by the EFS CSI, and then it's got a UUID with it, and then it's got a unique POSIX user for it. So the way that the driver is going to work is it's going to create an access point that is completely unique in both path and user. So this means every PVC that I create is going to be a different path. The app that comes in via that path is only going to see from that path and down, so they can't jump into another app's directory and see.
Like a cheroot.
Yep. Yeah, you'll cheroot jail kind of thing. And it's going to run that app as a unique UID GID, which means even if it did like happen to guess the file ID of someone else, it wouldn't have permission to it because it's running as a completely different user.
That's awesome. Can you go back and there was a question, where do you request the storage amount? And he thinks he saw it in pv.yaml. So could you maybe cat pv.yaml again for us?
Sure. So this was actually in the PVC config. So I requested storage 20 gig. Now, the reason I said nothing about this is because the only reason I put this in here was to make Kubernetes happy.
That's what I was going to ask, because I know EFS doesn't care how much storage you provision or use, or I mean, it cares how much you use, but like what happens, what's Kubernetes going to do if you use 21 gig?
Same thing. So, so the CSI and overall persistent volume framework allows for storage where you have to declare how much you want, because what Kubernetes is going to try on the back end is to match my request against available resources. So it says, I know that he wants 20 gigs. I'm going to go find something with 20 gigs free. The thing is, with EFS, it doesn't matter. 20 gigs is free wherever you look. And we tell the driver to just ignore this when stuff comes in, but you still have to put it because Kubernetes is going to bark at you if you don't.
Gotcha. Okay, cool.
Good question. Thanks for asking. So we have this path in here. We have this POSIX user. So let's refresh our ECS container. Oh, now I need to log in again. Oh, all right, fine. All right, so now I have my directory here. So let's actually now also connect to, where's my mouse? There it is. Let's connect to the EKS version of this container. Please work, there we go. Okay, so let's notice the difference here. So the difference is clicking on the wrong one. With my ECS container that's mounted as root, it has full view of what's going on in the file system. I see this directory. However, my pod running in Kubernetes only sees the directory of the access point. So that illustrates the whole subroot mounting kind of thing. And I can test, create a new folder in there. And because I'm in God mode in my ECS container, I can go in there if I want to, which is why it's not a great idea to have root containers, but it makes for good demos.
Can you click the little icon that shows the details on the upper right? I think it's okay. I was curious if we could see the ownership of the directory just to get at, you know, I think it's that one. Oh, but it doesn't show ownership either.
Yeah,
okay, well, no big deal.
Yeah, we're looking for like an LSL.
Yeah, I was just curious, but it's
well,
not
yeah. So
us.
we wouldn't see it here, but where we would see it is right here. So this creation info, I can go in here and kind of illustrate this a little bit. So when you define an access point, let's say I'm creating like an EC2 user access point. So 1000, 1000. What I'm going to do here, where's my directory? Directory's up here. So user 1000. So if I just put a directory and I stop here, it's going to assume that the directory is already created and make sure that I have access to it and stuff like that. But what the driver is doing is it's assuming the directory isn't created, and it's using this optional thing called creation info. And this is my opportunity to say, this directory is not going to exist. What I'd like you, EFS, to do is create it for me. And while you're at it, put these permissions on it. And those permissions are going to be, I want it to be owned by 1000, 1000, so that it matches me as a user, and I'm going to have access to my own directory. Make sure they match, or else you aren't going to get in. And then I'm doing POSIX permission 700, which means I'm allowed in, I can read and write, but no one else can.
I see up there above, you can also add in secondary group IDs. This is really powerful to be able to potentially allow like group read permission, whereas like one user can make writes, but then a bunch of other groups might be able to still read the data. That's really cool.
Yeah, essentially you can, and one of the ways that we designed this was traditionally all these user IDs and group IDs came out of LDAPs or Active Directories or something like that, and they were tied to users. And it used to work when those users would launch applications on their EC2 systems, and the apps would run as the user. But now that user is going to ECS or EKS and launching their app, and we wanted them to be able to have their same permissions on that app without having ECS have to go talk to LDAP about the user and all that kind of stuff. This cuts straight to the chase.
That's awesome. So there's a couple questions. One that's probably pretty simple is, what is this file browser app again?
This is, let me see if I can have it tell me.
Down the credits below logout, maybe?
Oh, yeah. File browser.
That's pretty big. Filebrowser.org. That's pretty cool.
Yeah, this one, and it lets you like, we built this container to have our own password built into it. All pretty easy to set up.
Nice. And then another question is, can more than one container write on a shared EFS at the same time?
Absolutely. Yep. So it's shared file system means that you can mount it from multiple pods, containers, and read and write from multiple pods and containers. It's actually speaking the NFS code, which means you can do things like lock files for reading, you can lock files for writing. So if you have two containers writing to different files, obviously there's no need for locks there because they're each going to be doing their own thing. If you have a shared file that you want to have different containers read and write from at different times, the safe way to do it is to have those applications lock the file, write to it, unlock it so that somebody doesn't come swoop in and write to it. But from the protocol, it's optional. You can roll the dice if you want to too.
Awesome. And one other question, can EFS serve as NFS?
Yes. So like I was just mentioning, we speak the NFS protocol under the hood. So you can, like if you're doing all of this with ECS and EKS, and then you just want to attach a EC2 instance or even an on-prem server, you can just do mount -t EFS or NFS, point at a mount target IP, and then you're off to the races.
Nice. And then, is it possible to enable encryption on EFS while provisioning it via PVC using the predefined SC?
Yes. So with EFS, there's two things to think about with encryption. One is data at rest encryption, which is on by default. So in this case, let's go to my file system. Whoop. So here I've got I'm encrypted. So whenever you create something from the console, it's by default encrypted. It's not hard to encrypt it from the API either. You just tell it you want to use your key or pass your own key. The other is data in motion encryption. So the way that we do that is under the hood, we run a TLS tunnel between your client and EFS, and then we run NFS over that TLS tunnel. That is with ECS an option. So if I go down here, we'll see transit encryption enabled. That's how I would turn it on there. With EKS, we actually made it the default when the CSI driver went GA 1.0. So you don't have to do anything special under the hood for your pod to connect using a TLS tunnel to your file system.
Nice. And then I'm not sure about this one, but I'm going to throw it up here anyway. What about Parquet file with EFS? Is that something that you find common?
There are customers doing it. I don't know if I would call it common. So like most often when I think of Parquet files, I think of data lakes and S3.
That's me too, yeah.
So maybe what I'll say there. So like we're a file system. We'll store whatever you want us to store. Where it's, I think, going to be most common to do Parquet files on EFS is if you're using EFS for ETL as part of your data lake. So it could be very handy to have, as part of just your overall data pipeline, pushing data into EFS and then have a container that's taking that data, writing out Parquet files and then transferring them into S3 or something like that, if you want to convert something from random read write to write once and analyze.
Cool. That's a good one. And there's some questions here about performance and comparing EBS with EFS and stuff like that. But I think I would probably just lump that all into, tell me about how you decide how. I know there are some choices you can make when provisioning EFS around performance. So what is your decision tree like there?
Sure. So I'll go back over to that panel. So with the two vectors of performance, one are the performance mode. So we have general purpose. This is the default, unless you tell us otherwise at some point in the provisioning, this is what we're going to give you. It's as opposed to max IO. Now, general purpose is optimized for latency, specifically metadata latency. And what that means is, if you're doing operations, so let's take a very simple example. What a lot of people do when they first get their file system in is they copy a directory with the files into it, so now that they have something for their app. General purpose is going to be much faster than max IO at that, because whenever you do any bulk operation on a lot of files, your client is going to open a file, write the file, close the file, open another file, write the file, close the file. And open and close are metadata operations that are much faster with general purpose versus max IO. And what you'll find is most of the applications that you're going to be running on EFS have more metadata operations than you think, and they're going to be a lot faster on general purpose. Where max IO makes sense is if you have a highly distributed app that is driving a lot of IOPS. So this could be, I'm doing distributed ML training again across 100 different containers. And the containers themselves don't really care about latency. They're more throughput intensive, and they just want everything else to get out of the way for getting them their IOPS. Max IO is probably going to be faster for those. But if you don't know otherwise, pick general purpose. The way to know if you are making the right choice is you go down to monitoring. Let's let this load. So we have this CloudWatch called %IO limit. This tells you how close you are to hitting the IOPS limit of your general purpose file system. This is a percentage of 100. So if you see this graph get to 80% and 90%, that might mean you have an application that is better suited for max IO. But again, most don't need that. The next thing is throughput mode. So the way that EFS works out of the box is the throughput of your file system is based on the amount of data that you're storing. So by default, so here we'll see that I've got no data in my file system, which means EFS is going to let me burst up to 100 megabytes per second as long as I have what are called burst credits. So it's like a token bucket kind of model. So if I burst credits, it's going to let me go at 100 megabytes per second. But those burst credits replenish at a rate proportional to how much data that I'm storing. And I've got no data right now, which means eventually I'm going to run out of those burst credits unless I start storing some data. So the good thing to do is if I know that I'm going to need sustained throughput and I know that I'm not ever going to have that much data, what I'm going to want to do is click Edit here and switch over to provisioned mode and tell EFS how much throughput I want, 10 megs, 20 megs, 50 megs, whatever it is. And that way it'll just always give me that.
Awesome.
And can I measure that through like the monitoring tab? Like, are there CloudWatch metrics available? So if I don't know what I need, I can derive that somewhere?
Absolutely, yeah. So just like we could measure, so we've got %IO limit for IOPS, we have percent throughput utilization for your throughput. So whatever your throughput happens to be based on the amount of data you're storing or your provisioned rates will give you out of 100% how close you're getting to that. So you know, if I'm never even getting to 50% and I have provision throughput turned on, I can lower it. Or if I'm getting close, I might bump it up, things like that.
Makes sense.
Very cool. There are some questions about can EBS also do share file system? Not really. It is in the context of EFS. What happens is you put in a persistent volume claim and it gets filled by an EBS volume, and that EBS volume gets attached to a pod. And so there are some settings. Do you happen to know? I want to say there is a setting where you can allow multiple pods to read and write, or to read from that EBS volume, but I think all those pods would still have to be located on the same EC2 instance. So at that point, I'm not even sure that it's worthwhile to do it, because there's a limitation. EBS can only be attached to one EC2 instance. So I don't think you'd want to go down that road for any kind of shared data. I think EFS would be a much better fit. Right.
And the other thing that you may have read on the EBS side is they have a feature called multi-attach.
Oh,
which, like on the surface looks like EFS. Now what multi-attach does is it lets you attach your block volume to multiple hosts. Now I don't think this works through containers or anything yet. But
yeah, that's new to me. So
so probably not then. So with multi-attach, another user commented that like the way to think about this is EFS is NFS or like a shared file system. EBS is a physical disk. Now, if you think about that in the context of multi-attach, it's like, what would my application do if it was sharing a physical disk with another application without anyone in between to say what's a good idea or a bad idea for what to do on that disk? You're going to run into like a lot of I write your data before you do, and corruption and things like that. So it's
a good way to get your files flattened.
Yeah. So like it's a great feature. Lots of people need it, but you have to realize that the feature is for applications that are written for multi-attach block volumes. It's not written for people that just want a file system run by EBS.
And also, it's just another key component here is EBS is still availability zone specific, right? So you still have to build your app, and if you're going the EBS route, you have to architect thinking availability zones. If you choose EFS, you don't have to think about what availability zone you're in, because EFS can span all the availability zones that you need it to span.
I like not thinking. That's
too.
Usually my go-to.
Now my colleagues will kill me if I don't completely muddy the water with you right now and mention that. So with EFS, recently we announced that you can provision, or you can create a single zone EFS file system.
Right. I saw that.
So what these are good for, so what you get when you have a single zone file system is it's about half the price, which is attractive for a lot of people who are price conscious. So what we see a lot of, even in container land, is people are willing to tie all of their workloads to a single availability zone, have a single availability zone file system for like dev environments and things like that, where you've got data, but you don't have the same failover requirements for it and stuff like that. And operationally, it's easy just to have it in a single zone. But like you guys say, it gets a little harder with production. So that's kind of what we tend to see for usage. Customers use one zone for the dev environment and regional for the prod.
Exactly. Yeah. There was one other question. It's kind of, I don't know, there's some loading to it, but basically NFS behind the scenes ?
The question may be about like, how is EFS built, which we often don't get into like how exactly stuff is built, but I will say that EFS was built from the ground up to be a cloud native file system. So it's, I guess, one piece of evidence that it's not just an NFS server behind the scenes is the fact that it's elastic. That you can put petabytes of data into a single file system without ever really noticing that you're doing it. But we use NFS as a protocol because a lot of things already speak it.
Yeah, I think that's where the sort of thinking comes from, is you can interface it using NFS, and that's great because, like you say, NFS is basically everywhere. But yeah, it's not like running some file server that you would at home or anything like that. So yeah, I answered this one. Awesome. Does EFS use the NFS protocol? It certainly can. This is a question I've actually had for a little while, but I've just never thought to ask you about it. There's the NFS way to interface, but then there's also like EFS : / Is there a real difference? What are some subtle differences, if so?
So under the hood, both are connecting via NFS. So for those of you that are like NFS protocol buffs, specifically what we're speaking is NFS version 4.0 or 4.1 will answer to both. Now to your question about like what is it when I install EFS utils and I connect, it's a helper wrapper around NFS. So we originally came out with EFS utils and had this EFS config when we introduced encryption in transit, and we're actually creating TLS tunnels under the hood. So what originally happened when you did mount-t EFS is we would take your file system ID, we would figure out how to connect to it via DNS, we would provision a TLS endpoint, we would connect to it, and then we would mount localhost. So we were just scripting things on the host to make it easy to connect, but it was still NFS v 4.1 under the hood. Over time, we added more capabilities to that, such as the ability to pick up your IAM credentials and use them to authorize, authenticate and authorize to your file system. So we're going to continue adding features, both mostly for convenience, but sometimes for capability to EFS utils. But it'll always just be setting up NFS v4 under the hood.
Nice. And that kind of answers this question. Do you have any alternatives to NFS? EFS is kind of a superset. So it's kind of an alternative, but ultimately not so much. You still want to be on an operating system that has good NFS support. So
yeah, so the one alternative that we can bring up now is we integrated EFS with AWS Transfer, which, to those of you that aren't familiar with the service, AWS Transfer is a managed service we have for creating like file gateways. So it speaks SFTP, and I think some other protocols. But so you can hook up an AWS Transfer gateway to a file system on the back end and then use SFTP as a way to interact with your files. I've obviously demoed a container version of a file manager. We have a team, or actually just a couple of guys within AWS that have been working on a Lambda version of that. So you can, I can paste a link in the chat in a little bit of a file manager that it's just a CloudFormation deploys a Lambda function. And then when you hit it, it dynamically spins up and then gives you a file browser type experience similar to what I showed you, only it's serverless. There's other ways that you can connect, but the primary front door is NFS.
Nice. Adrian asks, what are, in your experience, the most frequent use cases for EFS-backed storage with EKS? Does it make a good fit for stateful sets hosting databases?
So the most common use cases, so there's a wide variety. So I'll rattle some off of what I tend to see most often. So websites and configuration management systems. So your WordPresses, Drupals, Moodles, Magentos, those kind of things. Dev tools. So Git type tools, Jenkins, Jira, Artifactory, those kind of things. Image and video manipulation, FFmpeg, various OCR kind of tools. Data science tools and workbenches. So Jupyter, RStudio, even like machine learning training, customers run on us. And I'll say kind of database-like things. So I see customers running EFS under their consoles or their zookeepers, or even in some cases like search indexes, kind of like Solr, Elasticsearch kind of stuff. But notice the one thing that I've left out of this whole long list is relational databases. And while you can do it, like the protocol works and all that kind of stuff, generally, if you're running a production relational database, that database is going to want super low read and write latencies. And we've talked about how it's great that EFS is a regional file system because it makes it really easy to have applications that bounce between AZs and stuff like that. But having a regional file system means we're replicating data to multiple availability zones, which most relational databases don't have time for us to do. So for relational databases, either just outsource it to RDS or do it on EBS.
Or outsource it to RDS.
I'm gonna third that. Outsource it to RDS.
Yeah. So Adam, we're running up against time, but I know that you want to show us how easy it is to get EFS working with Copilot.
Let's do it. And I happen to I've just been dealing with workstation issues, but we're gonna just get into it. So just basically going off of everything that Will said, it was cool to see ECS, how you define your mount points from the container level, your EFS volumes, all in your task definition. Well, with Copilot, prior to that, Will, I believe, had to create the NFS file system, right? There was some steps that were involved to create that. With AWS Copilot, you don't even have to think that far. You don't have to build these things external to your service and your code. So I have a cloud file manager service running. It's not the same as Will's. Will's looked a little prettier than this one, but you can see I do have a file manager.
It's kind of meh.
Very basic, it's better than an Nginx demo. So you got to give me that. But so all I did here was to define my shared storage. And the way Copilot, if I want Copilot to build an EFS file system for me, all I have to do is have defined storage in my Copilot manifest file. That manifest file, I'm just going to define volumes. I'm going to just have this generic name for my volume. If I want Copilot to create it, I'm just saying EFS true. Here's the path. And then if I want read only or not. At this point, this is now when I launch this task, when Copilot launches this task, or when it builds everything, it's going to build the EFS file system. It's going to build the access points. It's going to create the IAM policies to allow for my task to talk to this file system. But that access is only granted via IAM, which is scoped to this particular task. So Copilot does all of that heavy lifting for us. So really all I had to do was say, I just need a file system. Now my application, you can see here my cloud file system. All I need is to just define what the root is, which is an environment variable. So here's where I store all of our files for our nifty cloud file system, which is running in Fargate. So literally in this environment, I'm managing my application code. That's it. EFS is managed, Fargate's, managed compute. So I just have to make sure my code works, and that's a pretty good problem to have. So anyways, awesome. I mean, that's pretty much it. I was able to deploy it. I have this running. I can add, I'm hoping after this most recent deployment, I'll be able to add a file. I messed with things and caused all sorts of problems, but anyways, that's pretty much it. So we have a file system running, and it was a Copilot service deploy. I just had this in my manifest, and we're good to go.
That's cool.
Nice.
So a couple of other questions have come in. What file system does EFS use? ext4? And, think about it not in terms of a local file system that your kernel, is aware of. It's a remote file system. So you don't have to know what, underlying file system might be being used for you at the service level. It's just you speak NFS to it, NFS v4 or v4.1. So that's all you have to worry about.
Yep.
Yes.
One like a different way of answering that is the file system is EFS.
Yeah.
I like that.
All right. So we have seen a deployment that went out using attaching EFS to an ECS task. We got to see it, with root level access. And then we also created a deployment using EKS that provisioned using the PVC, provisioned an access point in our EFS file share. We could then go back and see it using our root level access on ECS. And then you can see that if you want to get started with using ECS, if you're using Copilot, it's just a matter of listing a couple of stanzas, or really one, maybe two stanzas in your Copilot manifest, and it will go out and provision absolutely everything for you. And Adam's demo did finally work.
Yeah. Anyway, user error, but yes.
Very cool.
And someone did ask about a demo, and we just did last week. We had Austin on from the Copilot team, and he deployed a WordPress site using Copilot, and we had a shared file system using EFS. So I'm going to find that link, and I'm going to share that really quick.
I got it right here. Share, copy, paste to everyone. And I'll even pop it up on screen. Perfect. So yeah, this is fresh as of last week. So definitely check it out. And then also, just on that note, subscribe to our YouTube channel. You will get alerts as we go live with cool things like this, like last week, like stuff that we have planned for tomorrow. Going to be really cool stuff tomorrow. So definitely give us a subscribe, and then be on the lookout. We try to limit ourselves to an hour a day. We try to show you some really cool centered around running containers on AWS. So yeah, come back tomorrow.
Come back tomorrow. It's going to be cool.
Yeah, for sure. Will, thank you very much. That was awesome. And like I said at the beginning, EFS is my favorite way to manage state for my containers. So I'm always looking for some cool insight into how to do it better. And this whole access point thing is just really awesome.
Yeah.
Great. Thanks a lot for having me on. It was a fun hour, and I'm glad to have turned you around on the whole stateless versus stateful thing. You had me worried when you were kicking off the show, and you were like, no.
We're going to show you all the reasons why you shouldn't. No, I think we're there. I think we're ready for it now. So EFS definitely makes it easy.
Yes.
Cool. All right. Well, thanks everyone, and see you tomorrow.